Welcome back to the Deep Dive. Today, we are taking on, I think, the most crucial and often the most contentious moment in the entire product development lifecycle.
Mm-hmm.
That precise point where a beautiful, validated product idea stops being a set of screens and, starts being real deployable code. We're talking about the design handoff.
Yeah, the handoff is where the rubber really meets the road. It's that point where product intent, the why, has to be perfectly translated into engineering execution, the how.
Right.
And we've all seen projects where that translation fails. It just leads to friction, rework, and features that, they technically exist, but they fundamentally miss the mark.
Absolutely. The tension is just inherent, isn't it?
Yeah.
Designers are optimizing for the experience,
Yeah.
engineers for a robust, scalable implementation, and the product manager is, well, the ultimate owner of the outcome.
Right.
So our mission today is to understand the language that can solve that tension, that prevents that expensive chaos. We're focusing entirely on the one tool that guarantees clarity and measurability, the acceptance criteria, or AC.
And we've distilled a stack of incredibly detailed product management and UX documentation for this. Sources that are really focused on high-performance development workflows. We're looking at product requirements documents, or PRDs, the mechanics of the handoff itself, and critically, how to write acceptance criteria that serve as this clear, testable, almost legally binding contract of success for a dev team.
I like that, a contract. And the sources are meticulous, right? They focus heavily on the workflow inside organizations, where the PM owns the vision but doesn't own the pixel-level design details.
Exactly, the no design PM.
The no design PM. So for you, the listener, we're going to explain not just what acceptance criteria are, but why they are this indispensable bridge between abstract design and concrete implementation.
And crucially, how to define them in a way that is just utterly unambiguous and fundamentally focused on the user's observable experience.
I think of it this way. When you launch a feature, you're not just launching code, you're launching a promise to the user.
That's a great way to put it. And acceptance criteria ensure that when that feature lands, it keeps every single part of that promise.
Yeah.
Especially the parts you can't immediately see.
Okay, so let's start at the very beginning of this process. The handoff itself. Product research is done. The problem is defined. The designers have spent weeks iterating, testing, polishing user flows in Figma.
Mm-hmm.
So when is the design officially stable enough to actually move into engineering?
Well, the design handoff is formally defined as the point where discovery work is, deemed complete, and the design artifacts, the core flows, key screens, prototypes are locked down and approved. Lockdown. And critically, that stability isn't just visual. It means the PM is confident that the design addresses the core user problem from the PRD and that any further changes are going to be minor tweaks, not like big structural overhauls.
So you're preventing the engineer from starting work only to have the foundation just pulled out from under them.
Exactly. Stability means low design volatility. And for the product owner in this scenario, our no design PM, their responsibility is massive at this point, even though they aren't making the visual assets.
So what's their core mandate then?
Their job shifts completely. It's about ensuring total clarity and consistency. The PM is the primary guardian of the why and the what, even when the design team delivers the how it looks.
Okay, so that responsibility, it must manifest in a few key areas, right?
It does. 3 critical areas that have to be bulletproofed before handing that ticket over.
Let's start with the first one, intent.
The product intent has to be crystal clear. That means the problem you're solving, the desired business outcomes, the non-negotiable constraints like legal or security requirements, it all has to be documented.
So the engineer knows that building this feature actually serves a tangible business purpose. It justifies their effort.
Yes. And the second area is about the visual artifacts that the design team delivered.
The Figma files.
Right, but it's more than that. The design intent has to be universally understandable. It goes beyond just, pointing to the Figma file. The PM needs to make sure the team understands the rationale behind the choices.
Like, why is this action hidden behind a menu instead of being a primary button?
Exactly. Understanding those experiential goals helps the engineer make better implementation choices when they, inevitably hit some technical constraint.
And the third area, which is the core of our deep dive, that's the most granular, the most enforceable layer of clarity.
That is providing crisp, complete acceptance criteria. This is the PM's signature deliverable at the task level.
So AC translates the high-level design vision and the low-level technical logic into a checklist for success.
Precisely. It ensures both engineering and QA know exactly what conditions must be satisfied for the work to be marked done and correct, both functionally and behaviorally.
So the PM is really the ultimate synthesis engine, making sure the PRD, the Jira tickets, the Figma files, they all tell the same story.
Yes, because if an engineer is forced to spend time trying to connect the dots across 3 different tools, that's where inconsistency and therefore rework starts to creep into the system.
Okay, so let's talk about what the engineer needs. When a developer starts a new task, they're essentially looking for a contract, right? Something that removes ambiguity.
That's it. They need to understand what to build, why they're building it, and how they'll prove it works. To bypass that costly guessing game, they need 4 essential components at handoff.
Let's walk through that checklist. What's number 1? The big picture.
Number 1, objective and context. This comes right from the PRD or the story map. It answers the question, why am I spending my time on this? It ties the work to the bigger goal. Are we increasing conversion, reducing support tickets, improving retention?
Without that, motivation just tanks.
It really does. Okay, 2, design intent and final design. This is the visual source of truth.
So the link to the specific Figma flow.
Yes, the approved artifact, along with any dev notes from the design team, spacing, typography, motion notes. This tells them what the final result should look like.
Number 3, acceptance criteria, the behavioral contract.
This is the operational definition of success. It focuses on the system rules, the logic, the edge cases. It's the definitive answer to the question, how do I know when I'm finished and correct?
And number 4 seems crucial for efficiency, reference to the design system and reusable components.
It's so critical. Developers need a clear path to use existing elements. They shouldn't be building a new date picker from scratch if a standardized, pre-tested one already exists.
This ensures speed, reduces visual debt, and guarantees consistency.
Across the entire product.
The documentation we reviewed is really strict about this. It says if even one of these 4 pieces is missing, the process immediately defaults to a guessing game. What does that actually look like in practice? What's the real cost?
The cost is enormous, and it's usually hidden. If the AC is vague, the engineer has to make a product decision. They might implement, say, an error message logic that seems technically sound,
But which violates some UX constraint that the designer had in their head but never wrote down?
Exactly, or the PM failed to clarify. I worry that in the rush of a sprint, if the PM hasn't specified the error state behavior, the engineer will just implement the easiest technical solution, not the best user solution.
That's the path of least resistance.
It is. Let's say the AC failed to specify how a long list of search results should load. If the engineer just implements simple pagination, but the designer intended for infinite scroll to improve conversion.
That's an immediate, unexpected change request.
And that's wasted dev hours, a mandatory QA retest cycle, and a project timeline that's now slightly behind schedule, all because one behavioral constraint wasn't codified up front. That's the friction the PM is paid to eliminate.
Okay, now that we appreciate the high stakes here, let's zoom out a bit. If you're new to formal product documentation, it can feel like you're drowning in acronyms, PRD, AC, DoD, Jira. Where do acceptance criteria fit into this whole hierarchy?
It helps to visualize it as a pyramid, or maybe a documentation stack, where each layer provides more context and specificity for the layer below it.
Okay, so at the top, the strategic apex.
At the very top, you have the PRD, the product requirements document. This is the highest level source of truth. It defines the strategic why. It covers the problem you're solving, the business goals, assumptions, scope, what's in and what's out, and the high-level user stories. It guides the entire effort.
And then moving down, the next layer is the intended solution.
That's the design artifacts. So your Figma prototypes, customer journey maps, content guides. These tell the team what the user experience will look and feel like. They translate the PRD's goals into visual and interaction models.
And finally, at the base, where the work actually happens, that's where we find our criteria.
Exactly. At the granular level, you have the delivery tickets, usually in Jira. This is where work is broken down into implementable units. These tickets have the tech notes, the assigned engineers, and, most importantly, the acceptance criteria.
So AC takes the visual solution from the design and translates it into specific, measurable behaviors that the code must exhibit.
It's the final translation. Now, since our no design PM isn't drawing the boxes, they have to be this precise negotiator between UX constraints and pure design decisions.
What are the 2 types of constraints they have to agree on with the design team? And how does that feed into the AC?
Okay, so the PM has to clarify and codify two sets of rules. First, the user experience constraints. These are behavioral rules that dictate the flow and system logic.
Give me an example.
Something like, the user must be able to undo a destructive action for 5 seconds after confirmation. That's not a color choice. It's a fundamental safety net for the user.
And the second set?
The second set are the pure design decisions. These are the non-behavioral aesthetic elements. The exact hex code of a button, the margin size between components, the font weight. Those should live in the design system or Figma.
So the PM's job is to ruthlessly make sure the behavioral constraints, the UX rules, are pulled out of design artifacts and written down as acceptance criteria.
That extraction process is the most valuable part of their work. The sources we looked at call acceptance criteria the connective thread that ensures all these layers align.
So it connects the problem from the PRD
To the experience from the design.
to the final implementation in the ticket.
And if that thread breaks because the criteria are faulty, the implementation might satisfy the engineer's checklist, but completely fail to solve the user's original problem.
Okay, we absolutely have to clarify the boundaries here. As he gets confused with user stories, design specs, the definition of done. Let's make 3 crucial distinctions. First up, user story.
A user story is the strategic framing. It's that high-level description, you know the format, as a who I want what, so that why, for instance. As a returning customer, I want to reorder a previous purchase so I can check out faster.
That's the motivational goal, the desired outcome.
It defines the scope of the whole effort. And if the user's story is that high-level aspiration,
The acceptance criteria is the legal contract that defines if that aspiration was successfully met.
exactly. Acceptance criteria are the precise, testable, detailed conditions of satisfaction for that story. For our reorder story, the criteria might be: user can reorder from any order placed in the last 12 months, excluding gift card purchases.
That gives the engineering team a clear, testable boundary on the system logic. They can code to it, QA can verify it.
Precisely. Now let's draw the line between AC and design specs. This is where our no design PM has to be really vigilant to avoid micromanagement. Design files show how the solution looks, the layout, the visual hierarchy. Acceptance criteria, on the other hand, are focused entirely on behavior and observable outcomes. AC covers the logic, the rules, the edge cases that you often just can't see in a static design.
Okay, give us that reorder button example again, but let's really dive into the failure mode if the AC were missing.
Okay, so imagine the design file just shows a button labeled reorder. A lazy AC might say reorder button works. An engineer, focusing on the happy path, just implements a function that copies the last order into the cart.
But what happens if my previous purchase included a limited edition t-shirt that's now sold out?
See, if the AC missed that logic, the system might fail the user completely. Maybe you get a cryptic item not available error at checkout, or worse, it just clears your whole basket.
That is a catastrophic user experience. That's a lost sale.
It is. The strong AC prevents this by forcing the team to account for that recovery behavior. A robust AC would say, given a previous order contains items that are no longer available, those items are clearly indicated in the new basket with a disabled reorder status and excluded from the final purchase.
So the AC defines the intelligent system logic, not the button's color.
And if that's missing, you're punting a complex system decision to an engineer at 4:30 p.m. on a Friday. Good luck.
That distinction alone just highlights the value of AC as a risk mitigation tool. Okay, finally, let's contrast AC with the definition of done, or DoD.
This is all about scope and universality. Acceptance criteria are feature-specific. They apply only to the unique success conditions of one single user story. They change from ticket to ticket.
Whereas the definition of done is the team's quality bar for all work.
Precisely. The DoD is a team-wide universal checklist that applies to every single story. Things like code passes automated unit tests, feature is covered by a feature flag, technical documentation updated.
So both have to be met. The AC dictates what the feature must do to solve the problem, and the DoD dictates the quality standards for how that code was built.
You got it.
Right, so we know the why and the where. Now for the practical part, actually writing them. What is the fundamental official definition of crisp acceptance criteria? How do we make sure ours meet that bar?
The standard definition, and you see this cited by places like Atlassian, is that AC are clear, concise, testable statements focusing on the final desired outcome, not implementation details.
And they must be the definitive answer to the question the whole team is asking. We'll consider this story done when.
Yes. If there's any ambiguity in that answer, you risk failure.
Okay, to get that clarity, the sources give us 8 foundational qualities. Let's go through each one, because this is the critical self-audit list for any PM before handoff.
Let's start with what I'd call the clarity triad. Number 1, clear and unambiguous. If the criteria use, flowery language or jargon only one person knows, they fail. Unambiguous means if the PM, the QA lead, and the back-end engineer read it, they all reach the exact same conclusion about what the system has to do.
So if you write, the system should inform the user appropriately, that's vague.
It's useless.
But if you say, a toast notification must appear in the top right corner stating, update successful for 5 seconds, that is unambiguous.
Exactly. Okay, number 2, testable verifiable. This is the highest bar. If a QA tester cannot run a formal test and definitively mark the criterion as pass or fail, it has to be rewritten.
So a criterion like, the user should find the new flow intuitive is untestable. You can't put a pass-fail on intuition.
You can't. You can't verify it, so you can't accept it. Third quality is outcome-focused. We've touched on this, but let's reinforce it.
Right, distinguishing it from implementation.
The AC describes the behavior, what the user sees or experiences, not the code structure. Don't tell the engineer which database table to query. Tell them the observable outcome. When the user clicks Submit, the new data must be immediately reflected in their profile view.
This lets the engineer decide the best way to achieve that outcome.
Oh.
Okay, number 4, atomic. This speaks to the precision you need in complex logic.
Right. An atomic criterion checks one single thing. We often see the mistake of overloading, where PMs write these huge criteria using and.
Like the email address is validated, and the password must be between 8 and 16 characters, and the phone number must be optional.
That should be 3 separate testable criteria. If one part fails, the whole test fails, and you lose all your diagnostic precision.
Number 5, user-centered. How do we make sure the technical rules still serve the user?
By always framing them in terms of observable behavior. Instead of the endpoint return status 200, phrase it as, upon successful form submission, the user sees a success message and the form clears. It keeps the team tethered to the real goal, solving the user's problem.
Number 6 is complete enough. This sounds like a tightrope walk. How do you get to complete without it being exhausting?
Completeness means you cover the core happy path, the critical edge cases, errors, permissions, and any non-functional requirements that really impact the user experience, like performance. You don't need to cover every theoretical bug, but you must cover the paths that could lead to cart abandonment or data loss.
Number 7, realistic. This sounds like where the PM needs to have a tough conversation with engineering before they even start writing.
Absolutely. The criteria have to be grounded in the system's current capacity. You can't demand, say, real-time data streaming if the backend only supports batch processing every hour. The PM has to validate these for technical feasibility with the engineering lead before they're finalized.
And finally, number 8, aligned with PRD goals. This links back to our documentation stack.
Every single criterion must support the overall goals in the product requirements document. If the PRD goal is about improving privacy, a criterion must exist that explicitly verifies that. It prevents feature-level work from undermining your strategic goals.
This clarity, especially around non-functional requirements like performance, that's where weak criteria just completely fall apart. Let's revisit that contrast between vague and crisp performance criteria.
The vague one is the classic trap. The search results page should load quickly. A tester can't test quickly, and an engineer can't optimize for it.
So what's the crisp version?
The crisp version is a contract. On a 4G connection, the search results page loads in under 3 seconds for 95% of requests over a rolling 24-hour period.
That number 3 seconds for 95% is fascinating. It's so specific. How does a PM even arrive at a number like that? Doesn't that require technical negotiation?
It absolutely requires negotiation, and that's the PM's job. You don't just pull 3 seconds out of the air. The PM brings in the user research that shows cart abandonment spikes after 4 seconds, establishing the user threshold.
Okay.
They then present that to engineering, who assesses the technical debt, database complexity, and so on. Engineering might come back and say, we can hit 2 seconds, but it'll take an extra week of refactoring.
And the PM has to decide, is the cost of that extra week worth the 1 second gain in user experience?
Exactly. That final 3-second 95% metric is the product of that negotiation. A balanced constraint that addresses the user need while staying technically feasible.
Okay, now that we know the qualities, what about the formats? How do we actually write these down?
The structure you choose really depends on the complexity of the behavior you're trying to describe.
The easiest format for simple constraints is the bullet rule-based format, right?
Yeah, that's perfect for quick checks and simple rules. You just use bullet points for lists of constraints or validation. For example, all mandatory form fields must be visually marked with an asterisk, or the user must receive an email confirmation within 60 seconds of checkout. It's straightforward, easy to scan.
But when we get into user flows, state changes, sequential logic, we need more structure. That's the scenario-based, or given-when-then structure, the famous Gherkin format.
Gherkin is the gold standard for this because it explicitly isolates the three components you need for a testable scenario. It forces the PM to define the starting context. Given the preconditions, it defines the single action when the user does something. And it defines the required result, then the expected outcome.
Let's use a slightly more complex example than a simple login to show its power, maybe for a negative path.
Okay, good idea. Let's define a scenario for a permission failure. Scenario: unauthorized access attempt. Given the user is logged in but does not have administrator permissions,
Okay.
when they attempt to navigate to the admin settings URL path, then the system immediately redirects them to the default dashboard, and a non-disruptive inline message states, "You do not have permission to access this area."
See, Gherkin forces you to explicitly document that negative path, the recovery mechanism, the redirect, and the message, and the system state. If that's missing, an engineer might just return a generic 403 error page.
Which is terrible UX. Gherkin eliminates that risk. It acts like an X-ray for those implicit requirements. You can't just write, "The user can't access admin settings." You have to specify how the system communicates that restriction.
And the third format is using checklists for cross-cutting constraints.
Yeah, for complex features, we often combine the scenario format with simple checklists. This is to make sure those horizontal, non-functional requirements, the ones that are so easy to forget, are met.
Things like accessibility and analytics tracking.
Exactly. Checklist items like meets WKey 2.1 AA contrast requirements, or analytics event search performed is tracked with properties: search term, filter count, and results count. This ensures accessibility and data collection are core requirements, not optional extras.
The theory is solid. Now let's move into the actual workflow. The sources detail a 5-step process for translating a vague user story into a complete behavioral contract. Let's use a common e-commerce feature as our guinea pig.
Sounds good. The story is, as a shopper, I want to filter products by size, so I only see items that will fit me. Seems simple, but it hides a ton of system logic and edge cases.
Step 1 and 2. Clarify and align. We have to define the fundamental outcome and review the design artifacts.
Right. The fundamental outcome here isn't just filtering, it's enabling the user to shop with confidence and fit, which leads to fewer returns. Alignment means pulling up the design prototype and actively looking for implied behaviors.
For instance, the design probably shows the filter control collapsed by default. The PM have to clarify, is that always collapsed? Does the system remember previous selections?
Those are the rules that have to be codified. Then, step 3, identify core path and edge cases. Thinking beyond the happy path is non-negotiable here.
The happy path is trivial. Select filter, see fewer products.
The edge cases are where the value is. What message is shown if 0 products match? Does selecting one filter update the available options in other filters? What if the user navigates away and comes back should the filters persist?
You have to systematically detail all of these failure and state persistence requirements.
You do. Which brings us to step 4. Draft the criteria. Let's get into the details here, making sure we cover everything: functional, performance, accessibility, state persistence.
How many criteria would you expect for a feature like this?
Probably around 10 to 12 to adequately cover its complexity.
Okay, let's start with the core logic.
First, the functional core, inclusion logic. Given a shopper selects multiple size options like small and medium, then the product listing must display only items available in at least one of the selected sizes. That defines the Boolean or OR logic.
Then the filter control logic. When a shopper interacts with the size filter, the filter panel must remain open until the shopper clicks outside the filter boundary or explicitly closes it.
Exactly. That ensures usability. Third, the crucial edge case. No results state. We use Gherkin here. Given selected sizes result in 0 products, when the filter is applied, then a message must be displayed stating, "No products fit those sizes," and offer a prominent clear filters action.
That recovery path is vital. Fourth, visibility and reset. How does the user know what's active?
Currently applied size filters must be visibly highlighted using the design system's selected state token, and a single one-click clear all filters button must appear when one or more filters are active.
Fifth, let's get into the non-functional stuff. Performance. This is where we codify the speed requirement.
We incorporate that negotiated threshold. The filter must update the product list within 500 milliseconds for listings up to 1,000 items when tested on a simulated 4G connection. That 500 meters is the measurable contract.
What if engineering argues that 500 meters is too tight for their current tech stack? How does the PM justify holding that line?
The PM brings in the data. Maybe it's competitive analysis or A/B test data showing that slower filters correlate to a 15% drop-off. The PM can say, we accept the engineering effort required because our business objective is to reduce returns, and this latency target is essential for that. It's that negotiation that makes the criteria realistic.
Sixth, state persistence. This addresses system memory.
If the shopper navigates from the listing page to a product detail page and then uses the browser back button, the previously selected size filters must remain applied and visible. Such a major frustration point when that doesn't happen.
It really is. Okay, seventh, let's talk accessibility. WCAG. This is often left to the DoD, but complex components need specific checks.
Right, so the filter controls must be fully operable using keyboard-only navigation, and screen readers must correctly announce the current state of selected filters. This just guarantees inclusivity.
And an eighth one, a crucial business consideration. Localization. What if the company expands to a region using metric sizing?
When the user-selected locale uses the metric system, the size filter must display corresponding metric sizes. This prevents a simple cultural oversight from causing an international launch failure.
So by the time we have 10 or 12 of these, we've fully defined the feature across its logic, its presentation, its speed, and its inclusivity. QA can now write test scripts directly from these points.
And that comprehensive drafting process ensures that success is defined multilaterally. It's not just, did the filter work, but did it meet our standards for speed, accessibility, and negative path handling?
And the final step in the workflow is step 5, review with engineering and design. This is the crucial validation step.
The PM uses the AC as the shared document. They ask engineering, can you guarantee the 500 meters target? They ask design, does this accurately reflect the intended UX for error handling? If the answer is no, the criteria have to be adjusted or the scope has to change. The story is only ready when all three functions are aligned.
This entire granular process has to be anchored in the higher-level strategy. The standard PRD structure, like the templates from Atlassian, are designed to force PMs to make these connections transparent. How do the PRD sections inform the constraints in the AC?
The PRD is the foundational document, and its sections are direct ancestors of the AC. Well, first, consider the objectives and metrics section. If the objective is to reduce time to value by 20%, that directly demands specific time constraints in the AC. If the AC doesn't have a performance metric, the feature might be functionally complete, but a strategic failure.
Second, the assumption section. This is a PM's critical self-check.
Documenting assumptions is vital because they reveal technical constraints. If the PRD assumes most users will access this on a mobile device in a region with inconsistent 3G, that must translate into a specific performance constraint in the AC, like needing aggressive caching.
Third, supporting documentation. This manages the relationship between the AC and the visual design.
This is where you link the Figma prototype, but you explicitly state the division of labor. It's not enough to say, see Figma, you have to clarify. Figma is the source of truth for visual design. Acceptance criteria define the source of truth for all behavior, system logic, and testable outcomes.
That preempts the engineer asking, which one do I trust?
Exactly. And finally, you manage expectations with the out-of-scope section.
This prevents that catastrophic scope creep during handoff.
If you explicitly state, no advanced filter saving in V1 or no keyboard shortcuts in V1, you prevent the engineering team from asking about and maybe even building functionality that isn't intended for this release.
We've covered the fundamentals and the workflow. Now let's explore some high-stakes scenarios and advanced techniques. Let's contrast how weak criteria lead to predictable failure and how strong criteria manage that complexity.
Okay, let's take a high-touch, high-importance feature, the onboarding checklist. This is so critical for new user activation.
The weak criteria here are always something like checklist looks clean or it's easy to complete the steps. Totally useless.
The improved criteria address the entire journey state, speed, edge cases, for instance, state transition. When a user successfully completes the first mandatory step, the system must register the completion and transition the checklist item to the completed state within 1.5 seconds. Notice that aggressive speed target tied directly to the activation funnel.
And what about visual robustness across devices? That's a common failure point for checklists.
You add a specific responsiveness constraint. On mobile viewport widths below 480 pixels, the checklist must automatically collapse into a concise progress bar, ensuring no horizontal scrolling is required. This is a definitive constraint that prevents a massive visual defect.
What about when you're done?
We have to account for the final state. Once all mandatory items are complete, the checklist module must automatically disappear or transition to a compact, non-intrusive summary element. This ensures the checklist doesn't just become visual clutter for an activated user.
Let's move to probably the highest stakes area of all, error handling for failed payment. Failure here is immediate material revenue loss. The criteria have to be flawless.
The complexity here is that you need to address different failure reasons with different user experiences. The message for a system crash can't be the same as the one for insufficient funds.
Right, so scenario 1, card declined, insufficient funds. This is a recoverable error.
The criteria must keep the user in the flow. You need a clear, non-technical inline error message, and the criteria must mandate recovery options. The user must be immediately offered an option to enter new card details or select a secondary payment method without losing their cart contents.
Okay, scenario 2, system or connectivity issue. Here the priority is system integrity, not just losing the one sale.
Exactly. The criteria have to prioritize resilience. The user sees a non-technical error message, but the critical system-level criteria must be. Upon retry attempt, the system must guarantee that a duplicate order record is not created in the database. QA has to verify that back-end logic.
And we can't forget the business requirement, learning from failure. The analytics requirement is essential here.
Absolutely. The final piece of criteria ensures you can diagnose failures later. The system must fire an event payment failed with the following properties: reason code, payment method type, and order value. This event must be tracked regardless of whether the user retries. The PM uses AC to guarantee data integrity.
Now, writing crisp AC means actively avoiding some common mistakes that just plague product teams. We need to be able to spot these anti-patterns immediately.
Let's run through them. Number 1, vague adjectives and subjectivity. This is the easiest trap for any PM to fall into.
The feature must be robust, or the design is elegant.
Exactly. You're writing pros, not criteria. These are non-measurable. The fix is to substitute. If you want robust, define the error rate. If you want easy to use, define the time or click requirement. Remove subjectivity entirely.
Number 2, design by criteria. This is where the no-design PM oversteps their boundaries and undermines the design team.
The AC must focus on behavior, not aesthetics. If you specify, the primary button must be dark blue with hex code #1A2B3C, you're managing appearance. That belongs in the design system.
The AC should only state the behavioral rule, like the primary CTA must clearly indicate the successful action.
Right. If you specify pixels in AC, you create manual maintenance work every single time the design system updates.
I worry that PMs do this when they don't trust the designer or engineer will pull the correct token from the design system. How do you coach a PM to trust this system?
You coach them on the cost. Every time you manually specify a color in a JIRA ticket, you are creating technical debt. The moment the brand updates its palette, you now have a hard-coded bug in a feature that should have automatically inherited that change.
Number 3, overloading and the multi-story ticket.
If you open a ticket and find 30, 40, 50 acceptance criteria, you've committed the sin of overloading. The story is too big, it's trying to solve too many problems.
It makes estimation impossible and testing a nightmare.
Exactly. A good rule of thumb. If the AC list exceeds 10 to 12 points, look for a logical break and split the story into smaller, more atomic units.
Number 4, contradictions with strategic documents.
This is a failure in that alignment step. If the PRD mandates GDPR compliance, but the AC defines a new user tracking cookie without mentioning consent, you have a contradiction that could lead to real legal risk.
Number 5, missing negative paths, a classic oversight.
Focusing only on the happy path assumes perfect users and perfect systems, neither of which exist. Acceptance criteria must explicitly define what happens when the user enters invalid data, when permissions are lacking, when the network disconnects.
If you don't define the error states, you guarantee inconsistency.
And finally, number 6, writing criteria too late. This ties directly back to our handoff discussion.
Right. If the criteria are drafted after the sprint starts, you're guaranteeing expensive rework.
The AC is the definition of success. It must be ready before the work is estimated and planned. It's a prerequisite for sprint planning, not a footnote.
Okay, we've broken down the anti-patterns. Now for the final quality gate. Before any PM pushes that button to send the ticket over to engineering, they need to run the PM readiness checklist. 6 final questions to ensure quality control is absolute.
These questions force the PM to objectively measure the quality of their own documentation.
Question 1. Does the story have between 3 and 10 clear, testable acceptance criteria?
This checks for that Goldilocks zone. Not too vague, not too overloaded. If it's outside that range, a red flag goes up.
Question 2. Are criteria written for both the core path and the most important edge cases?
A mandatory check on completeness and risk mitigation. Did we remember the zero state, the logged out user experience?
Question 3. Are critical non-functional aspects, performance, analytics, accessibility, localization covered where they materially impact the user?
This ensures that the standards of a modern professional product are baked into the requirements, not left to chance.
Question 4. Are the criteria consistent with the PRD objectives and the latest approved Figma designs?
The alignment check. This prevents strategic or visual misalignment from hitting production.
Question 5. Have the criteria been validated for feasibility with engineering and fidelity with design?
The required sign-off. As we said, criteria that haven't been reviewed are just the PM's opinion. Validated criteria are the team's contract.
And the final question, the gold standard test of quality. Could QA write test cases directly from the criteria without clarification or guessing?
If QA cannot write a test case without asking the PM, well, what happens when? Then the criteria are ambiguous and have failed. If the answer to that last question is yes, the story's truly ready for development.
And if the answer to any of the 6 is no, the story gets pushed back to the PM for refinement.
Pushing an unready story forward just passes friction onto the next person down the line.
This deep dive has shown us that acceptance criteria are really the operational blueprint of product success. They're the universal language that translates that abstract product intent, the problem we're solving, into concrete, measurable, and testable engineering tasks.
They just elevate the entire development dynamic. They move the team from a system where everyone interprets the goal differently, that guessing game, to a state of testable done, where everyone shares an unambiguous, verified definition of success.
You know, what's truly insightful is recognizing how this comprehensive framework defining success based on verifiable user behavior and systematically accounting for every failure state can be applied far beyond just software development.
Right. Think about defining success for any complex initiative in your own career or life. A massive organizational change, launching a personal brand, even achieving a specific fitness goal. If you frame your objectives with this kind of rigor, you immediately eliminate the risk of subjective interpretation.
So the challenge we'll leave with you, the listener, is this. Identify a major objective you're currently pursuing, where the definition of success feels, a bit vague or subjective. Apply the Gherkin format to one of its critical failure points. Define the given context, the precise when action, and the specific measurable then outcome.
Because when you master the anatomy of acceptance criteria, you stop hoping for success and you start engineering it. By making the conditions of your goal explicit, testable, and aligned with your constraints, you move toward verifiable, guaranteed achievement, regardless of the complexity of the project.